Hello guys, welcome back. Let's solve this question. It says this is composite function. If f of x is x squared plus 1 and g of x is x minus 2, find the following. So this is composite function. It says f of g of x. This can also be written as of g of x. Okay, so it simply means that wherever you see x under f of x function, which is, remember, f of x function is x squared plus 1. So wherever you see x here, you replace it with the g of x function. So you just substitute. So instead of this becomes x minus 2 and you square it plus 1. Now if you expand this, you are going to have x squared minus this. You multiply this becomes minus 4x. Okay, then plus 4. Then you add this plus 1. So your answer becomes x squared minus 4x plus 5. That should be easy. Now what about the opposite, which is this b? It says g of f of x. So this again can also be written as g, open bracket, this is f of x. Same thing here. Wherever you see x under the g of x function, replace that with the function with this f of x function. Remember, g of x says x minus 2. Wherever you see this, replace it with this function. So that becomes x squared plus 1 minus 2. So this is x squared plus 1 minus 2. The answer here becomes x squared minus 1. Easy. Okay, then do for the last one. It says f of g of 3. Okay, so deal with this first. So this simply means f of g of 3. Okay, so here, because this is not x, first of all you have to deal with the inner function. Okay, what is g of 3? So you replace wherever you see x under the g of x with 3. So your g of x, which is x minus 2, your g of 3 becomes 3 minus 2, and that is 1. Okay, so the whole of this now becomes f of, instead of g of 3 now becomes 1. Okay, so now this simply means again, replace wherever you see x for f of x function with 1. So that becomes, remember, your f of x function is x squared plus 1. So instead of this becomes 1 squared plus 1, and the answer here becomes 2. So hence, the whole of this becomes 2 as your answer. Easy. Follow for more and subscribe to my new YouTube channel, please. Thank you.